Hey, hello and welcome back to Lochaber Stainless. Tonight we're going to talk about some of this CNC work that I've been chipping away at. Get it? So the stock has arrived for the tombstone. I had an initial bit of machining work done by my friend Paul at Morburn Engineering down on Halen Island. So this is a solid piece of EN8, an engineering steel. It's too heavy for me to lift right now, so when we put that in the machine, that'll be actually getting lifted in with probably going to be the engine hoist, so I can get it in because I don't want to be dropping that on my fingers. So this is what I showed in, was it the first video, I think? So we're going to be, or at least I showed the CAD cam side of things and the concept of it. So the ball's rolling with that. The idea is basically this is going to be machined into a big hexagon to allow us to make these flanges in a more efficient manner. So the 6 of those will be positioned around. Now they'll actually be face down, so they're machined to width and to a finish on the top side, and then they'll be put in upside down, at which point then the machine will come in, skim it flat, drill the holes, pocket, and do a weld prep for us. Now the main advantage with this is going to be time and efficiency, which is what we all kind of strive for with CNC, but with making, I make these a couple of months worth at a time from flat bar. Now there's 6 tool changes goes into each one, and it's a cycle time that I've been gradually trimming down and optimizing. So I've got that down to about 6.5 minutes, which basically means that when we're running these, you're next to the machine the whole time, you're plodding away, and you can't really do much else apart from stand by the machine. So this will allow us to do 6 at a time, which then takes us to approximately half an hour of runtime, which is more useful because you can actually do something that half an hour. You can do a bit of welding, or you can be more productive. And the other thing is that it can do the 6 flanges worth of each tool. So it's still 6 tool changes, but for that 6 tool changes, I'm getting 6 parts, which is just generally just less wear and tear in the machine and a more efficient use of time. And keeping it on this, using the 4th axis, that's saving. It saves a lot of cleanup. It saves space. It's not running the whole table, and as it's machining one, the coolant's coming down, it's blasting through, and it's that that those chips are going to accumulate below the part. Because our first project, well, not project, but when I first started doing this, I used to do them on this fixture plate. And it was a similar kind of setup. Let's make 6 at a time, and they were held in place with these cam clamps. So this was actually done with 3 long lengths, and then it would part them off and machine them to size, skim them to 3. And that worked great. But one of the difficulties, which I hadn't foreseen at the time, and looking back, was chip control, because you machine all these parts, the whole thing's covered in chips, and then you've got to spend ages cleaning it out before you can put more back in. So this is where this has come from now, that sooner or later, at some point in the program, the part's going to be upside down, in which case the chips are going to fall away. So chip control's massively improved with that. Another little job that I've got just now is a job for a gentleman in London making these parts, and so this will be an assembly. We've done a sample as well of the finish, so the job spec is for a media blasted finish, and you can see the little holes for where they bolt together, so these will bolt back to back like that. I've still got the second operation to do, and they're going to be bolted together with M2 Torx screws. And it was quite interesting there. I'll show you this. Is a 2mm tap. I think that just gives most people the fear looking at that, because I don't even want to look at it too hard in case I break it. So yeah, will be there. So the machine has a proper, I have for the machine a proper tapping chuck, which has some axial compensation, so it's a fixed tool holder in it and it spins, but it allows for any kind of back and forth, so it's a bit more forgiving. I have it in I've got a 6mm in there just now, and at the moment that tool has somewhere in the region of 1600 holes in stainless. So the concept definitely works and it's proven itself very reliable. So I'm quite actually looking forward to giving the little fella a go and seeing how it copes with that. Should be perfectly fine in the machine. It's all going to be down to how well I program it, I think, is going to be the crux of it. And then other than that, from CNC, I thought I would show you this, which is, we fabricated this for another local engineering company who do a lot more site work than we do. And they asked for a beacon mount for the back of their van. So this is going to bolt up onto the roof, 2 work lights and their LED flashing beacon. And that's all, made from scratch. And here that starts with us as straight tube. That's bent on the bender to size and fabricated. So I think they're picking that up tomorrow. Well, won't be tomorrow, but in the next couple of days anyway now. So this is something that we can certainly provide for a lot of things. Next week we have a lorry in to get a full set, so he's wanting roof bars and lower bars. So yeah, it's another thing that not everybody knows we can do, but we certainly can. So if you want one, give us a shout. And at that, I'd say thanks for joining us, and make sure to like and subscribe if you want to see more, and I'll see you next time. Bye for now.